Okay, so here's one that you do not know the formula for how to take the derivative on this from what we've talked about. So I don't want you to do any calculating. But what I want you to do instead is try to reason it out, what you think this looks like. So what we got is a right triangle whose one side is always 3. Then this other side is some variable distance x. We could even say it starts out at 0 and just grows higher and higher. Okay? And what I'd like you to think about is how does the length of the hypotenuse change for different values of x? And that's going to be what the derivative of the square root of x squared plus 9 looks like.
Well, I think the hypotenuse will get longer and steeper as x grows.
Okay.
Because it has more distance to go, and it's going to get shorter when x gets shorter.
But it never can shrink past 3.
Ah, okay. So you got some good intuition going on right now. So it's the smallest it can ever be is 3. And when does that happen? Can you tell me?
Well, it happens when it's, well, it can't really be 3 because then it would just be like a line.
Okay.
It can be like a little larger than 3, and then it's when x is like a really small amount.
Okay. And you think the hypotenuse, as x grows larger, the hypotenuse always grows larger too?
Yes.
Okay, what's that going to mean about the derivative? If as x gets larger, the hypotenuse also gets larger?
So the derivative should keep getting steeper. Or I guess bigger.
Well, we haven't talked about how derivatives grow, but if the hypotenuse is growing while x is growing, that tells you something about the derivative.
Well, so I want to find the derivative of this.
Yeah, but let's back up. If this hypotenuse always grows as x grows, what does that mean about the derivative? It tells you something very simple about the derivative.
Well, it's always positive.
Okay, why?
Because the derivative never has to go in a negative direction.
Okay, what would it mean if the derivative was negative? What would it mean about the length of this?
Well, it would be either shrinking or...
Okay, as x grows, this would have to shrink for the derivative
But it
to
just
be
doesn't
negative.
make sense.
Okay, so one thing is the derivative is always positive. Okay? Does that make sense? What do you think the derivative of the square root of x squared plus 9 looks like as x is very near to 0 and just starting to grow? Do you think this grows, the expression square root of x squared plus 9 grows quickly? Do you think the length here, as this length starts to grow, do you think it's growing fast or do you think it's growing slow?
I think it's growing pretty slowly.
Mm-hmm.
Okay, why?
Because when it starts here, to get from this point to this point, it only has to grow. It only has to go a certain distance, but as you move up the line, the line has more distance to travel to get to the side.
Okay, so you think it starts growing a little faster?
It starts growing faster once x gets bigger.
Okay.
Makes sense.
And what do you think about when x is very, very large?
So
as x is near infinity, what do you think is happening to the square root of x squared plus 9 as x grows?
Well, that's just getting closer and closer to x.
Why?
Because the 9, like if x is 10 billion,
Uh-huh.
the 9 doesn't matter that much.
Okay.
10 billion plus 9 and 10 billion are pretty close to each other.
All right, so if it gets closer and closer to x, what's its derivative going to be?
Is it just going to be x? Or the derivative of x is what we want?
Which is what? Think of the derivative as being slope.
The derivative of x is...
It's going to be like, it's
just 1.
Right, because the line y equals x is just a line,
Yeah.
and its slope is
1.
1. Okay, so as x grows, you guys think the derivative starts out growing slowly, we'll sort of say near 0, and then it grows somehow, and eventually grows, but the growth rate is stopped at 1. So maybe it looks like that. So it grows, this line grows faster and faster, but then its growth slows down a little bit because the growth can never be larger than 1.
Yeah.
Interesting.
Or maybe it grows really fast in the beginning, and actually the growth grows above 1, and it does grow faster than x, but it comes down like that, back down to 1.
Cool. It's possible.
It's possible.
Yeah.
Okay. All right. So that's 1, and we'll see what this looks like upstairs. Okay.
Okay.
Now we've got a second challenge question.